All right, great. So welcome. Thanks everyone for making time to join Groom's monthly webinar series. I know that it's tight. It's at the end of the quarter and it's kind of rolling into vacation time. So we do appreciate everyone's focus and interest in this topic. It's been a very exciting one, and we're happy to present it. So we've got folks, I'm looking at the registration list on this webinar, mainly from the power and refining petrochem side. We welcome folks on the power side from the gas, coal, and waste to energy areas, as well as the refining and petrochem spaces throughout the country, as well as a few others. So that said, there are a few different industries represented and a lot of different types of plants and equipment to kind of go over. So we're going to cover that as thoroughly as possible over the next 30 minutes. In any of your plants, no matter how different they are, there are some assets that just get more attention than others. Some you've got a proactive plan for, and others not so much. I think that's a fair statement, right? If you don't have time, or if you don't have a plan for your fins, your boiler tubes, your ACC, etc., this might be an informative presentation for you. I certainly think it will be. Now, if you do have a plan, but you always use the same method or you always use the same contractor, yet you expect better results, this will also be a very informative presentation for you. And we're excited to chat on this topic. A little bit of housekeeping. We're going to discuss the foam, the clinging foam technology, which is new and exciting, and also the dry ice technology. Both are great, but definitely have their strengths and limitations, pros and cons. We're going to review all of this on both sides with each method, so you can accurately pick the best technology for your next project. Now, sometimes the features and benefits of these technologies aren't always enough to realize the value with your specific application. That said, we're going to bring some case studies in from experiences we've had in the field in different industries, so you can try to relate to those and maybe make a better decision at your plant. I don't think any case study is a case study at the end of the day without an ROI attached to it, because understanding the dollars and cents are always just the best justification for me anyway. I know everyone's excited to hear how much money they could potentially save or how much efficiency they can drive into their job and their equipment. Once we're completed, we're going to leave some time for questions at the end. So if any questions do pop up, throughout our presentation, please feel free to jot those down, and Ray and I will address those at the end. Once the webinar and Q&A session is complete, we'll make sure to get a video link out to everybody so you can reference it once you do have time. If you do have to hop off of this early, completely understand. A little bit on the introduction side. My name is Steve Houghton. I'm the VP of Sales with Groom Industrial. We've got 6 different divisions that specialize in different services. Today, primarily, we're going to be discussing the HRSG, refinery, and industrial cleaning areas. So thank you and welcome to all the customers from those groups. We also welcome Ray Langton, who's got well over 2 decades of experience in the refining, petrochem, and midstream spaces in the environmental cleaning side. He also served head of residence at a refinery, so he knows the ins and outs and can put 2 and 2 together and help solve problems at your plant. That's what we're here for. So we welcome Ray and his insight on the foam technology later on in this presentation. So let's just start off from 30,000 feet. What exactly does a foam or dry ice application look like, and what does it entail? I'm just going to park here for a second just to give everyone a visual. On the left, you'll see a clinging foam. there's a lot of different varieties, whether they're off the shelf or custom, of different formulas to apply to different applications, depending on what needs to be cleaned and what's on those tubes, what you need to liberate. The dry ice in the picture to the right, see one of our guys, dry ice blasting. Basically, dry ice looks like little pellets of white rice. It comes in an insulated tub about the size of a washing machine. And depending on different factors, it's got a shelf life of about 3 days. So just a high level view of these technologies, and we're going to dive a little bit more in depth on each one here. So first off, we want to talk about applications, and I want to take the chance to clear some of the nomenclature out between the different industries. The picture on your left here, you see boiler tubes and a HRSG at a gas turbine power plant. So these would be referred to as boiler tubes in the power gen space. Similar design would be referred to as fin tubes on the refining side. So if you hear one or the other, they kind of go hand in hand in the basic layman terms anyway. We're also going to discuss fin fans, ACC, and other cooling equipment. These are great applications for foam or dry ice, depending. And also, general cleanup around your plant. It doesn't need to be cooling equipment or tubes to employ these methods. So boiler tubes or fin tubes. Primary function of this asset at your plant is to capture heat and process steam for different uses, whether you're making more power through a steam turbine, using it in a process downstream on the petrochem or refining side, a little bit of both. Either way, if gas flow is hindered or heat exchange rate is hampered through those tubes, you're not operating at optimal production capacity. So some forms of blockages or foulants on these tubes might be in the form of corrosion, might be rust, which are obvious to the naked eye, could be debris, anywhere from dirt, pollen, bugs, etc. The nasty and common one is ammonium bisulfates. You'll notice that it's a white substance that'll accumulate on the tubes, or it could be any one of a litany of process-oriented foulants. You see that often on the refining and petrochem side. So no matter what the blockage is on your tubes, it's one and the same. Basically, you're decreasing your heat exchange rate, you're increasing your back pressure, you're decreasing potential megawatts, and increasing operating costs. So a clean and unobstructed tube could serve exponentially on the back end. Now, you might be familiar with other cleaning methods, but you want to use foam. There's 4 main factors to consider when looking at different methods. First off is tube orientation. So in this particular example, we're looking head on at a vertical HRSG boiler tube. This is not going to be an ideal situation for foam because it's vertical. You want to remember that gravity is foam's best friend. So if we are looking down on this tube instead, you can imagine the clinging foam working evenly around all 360 degrees of that tube. So working in blind spots on around surfaces like this, deep bundles, etc. That clinging foam could be the hero. In vertical application, in HRSG tubes, dry ice many times is going to win out. You want to consider bundle depth as well. If the ice cannot effectively clean in the middle of that bundle, foam might be your best choice, again, in a horizontal orientation. The distance between the tubes is something to consider as well. So if you take this picture as an example, that tube itself is a few inches wide. but we've only got so much space between them. If you're going to have an issue safely getting any kind of mechanical cleaning equipment between those tubes, foam might win out or be the hero there. Finally, the material on the tubes definitely needs to be considered. Ice, dry ice or CO2 is going to be a great answer to salting or something along those lines, but foam is definitely very cost effective, and we're going to go over why in Ray's section a little bit later. Now, every unit is unique, and answering yes or no to these factors isn't necessarily going to get you to your answer. We're certainly there to help you and inspect your unit design remotely. We can do a physical inspection on your actual unit, or actually take a sample of that foulant and determine the best solution to clean effectively. Now, every different asset needs to have different considerations in mind. Case in point, fin fans, ACCs, anything along that line of assets. We need to consider the material here. It's a thin gauge metal, most times aluminum. Now, dry ice done properly is effective, but it could pose a risk of damage if it's not done professionally and properly. Aluminum is soft and the fins are light gauge. So we can consider foam here as a cost-effective and safe way to get the job done. There's two factors here to consider when looking at this, and it's scheduling and zoning. Scheduling and how many man hours are you taking to complete that job? That can be a direct impact on cost, and foam can certainly assist there. And then zoning. We can manage a few fans at a time while they're off to minimize your downtime and get your entire bank back up running. Almost good as new. Now, as I mentioned before, foam is not a one-trick pony, nor is ice. Both are versatile and should be considered for many other types of cleaning around your plant, outside of just the tubes and cooling equipment. One example of a project along these lines would be transformer or switch boxes after fires. Now, any mention of fire, obviously the nature of the work would be emergency. One thing to consider with dry ice is the production for dry ice typically weekdays. So if you have an emergency cleaning needed on a Saturday or Sunday, your dry ice might not be available, whereas foam could be. Few examples of common foam jobs could include diamond plates, walkways, platforms, etc. There's a million different surfaces where this could be a big win. You take that gear, sprocket, all those general bearings as an example, covered in grease, and picture your walkways around your plant or your facility. Not only could eliminating that grease be better looking, but you're also taking care of potential safety hazards. So it's a quick high-level introduction to each method. I'm going to pass it off to Ray to discuss a little bit more on the foam application. Right?
Thanks, Steve. Again, my name is Ray Langton. I'm a regional sales manager with Groom. I've worked for the past 20 years in refineries. We have a lot of folks on the call today. Some of you I've met, some of you I haven't met. If I haven't met you in the next few weeks, I'll reach out and try to introduce myself. But at the end of the presentation, Steve's email is listed and my email is listed. We will have a Q&A section, but after today, if you have a question, please feel free to contact Steve or myself. We'd love to help. I did spend 10 years with a chemical cleaning company doing foam cleaning. We had great results. And today I'd like to discuss some of the benefits of the foam cleaning process. This year, especially in our industry, companies are struggling, budgets are getting cut, a full turnaround or an outage may not be possible. We've all seen it. We actually have a customer on the call today who was supposed to replace a convection section on a heater, but due to budget constraints, they can't do it. So they asked how we can help increase the production, and that's what we're trying to do here today. So when your management team asks you, how can we save money? After today, you can actually tell them how you can not only save money, but also increase production and profitability at the same time. And this is how we can help you do that. Our foam cleaning is a low pressure, high volume process where the foam entirely encapsulates the tube bundle. It rests for a predetermined amount of time, and then it is simply rinsed away. The typical crew size we use on a cleaning, we usually have 3 technicians. We'll have 1 technician doing the application. We'll have 1 technician on the ground monitoring the pumps and the solution, and then we'll have a safety watch. Equipment that we usually need, if no plant air is available, we would bring in a compressor. For interior cleaning applications, we would bring in a vac truck to help clean up the solution in the containment area that we would build. And the final piece of equipment that we use is a bucket lift. And I can't emphasize that enough. If you look at websites, you can see some other companies where they have people that don't have fall protection that are walking on the fans, walking on scaffold planks across the fans. Please don't do that. If they fall, this will be the most expensive job you'll ever do. So please have a technician in a bucket with a harness and a lanyard. Foam works great in confined space. With fin fans, there's usually good access to the tops of the fans, like I just mentioned, using the bucket lift. With dry ice, you need good access for the crew and the equipment. But with heaters, boilers, furnaces, many times we've seen there's limited access. There's usually just a top hatch and a few doors at the bottom of the unit. And the foam works great in this situation, and we'll explain that coming up. The solutions we use are biodegradable. For fin fans, the solution is able to drop to the surface below, whether it's stones or concrete. So in addition to your fin fans, you'll have the cleanest rocks, stones, concrete around. If EHS wants us to cover the sewers, we can do that gladly. We can install bird baths over the sewers. In that case, the solution will just dry on the ground. For interior applications, normally scale, we use a foam solution that dissolves the material. We'll install containment at the bottom of the unit and collect the solution in the vac truck like I mentioned. After the cleaning, we check the pH and we can adjust the solution as needed, typically using sodium hydroxide. I have worked for a waste disposal company, and off-site waste disposal is expensive, and so we try to minimize that as much as possible. For rust and scale, usually interior applications, we use a blended acid package. In this solution, the hydrogen atoms are balanced, so there's no odor. Work can go on around where we're working, other companies, with no danger to them. It is non-corrosive. You can put your hand in the solution with no harm. And again, if EHS wants more information on the solution, we can provide that before we do a cleaning job, no problem. For calcium removal, we use a blended salt solution. It is a low pH combination of organic and inorganic salts, and they perform like an acid. And this will replace other cleaning acids such as hydrochloric, a more hazardous cleaning acid from an EHS perspective. And again, the calcium removal is non-corrosive and is safe to touch. Foam is a good choice for pretty much anything. Whatever you find, oil, wax, bugs, pollen, some situations, cottonwood, sticky valance, whatever you find on the front radiator of your car is pretty much what you're going to see on a fin fan. So what we use is a proprietary blend of solvents and surfactants that actually lift and separate the dirt molecules, allowing them to be rinsed away. We've been asked about hydroblasting. We tend to stay away from hydroblasting, number one, for the safety issue. Number two, hydroblasting can damage the fins. And a third problem is when you're hydroblasting a tube bundle and you only have access to the top and the bottom of the tube bundle, the hydroblasting can actually compact the debris tighter into the tube bundle, creating an even worse situation than we started with. So we're trying to stay away from hydroblasting as much as possible. Typically, when we do fin fan cleaning, we'll see a 20 to 30% drop in tube temperature, again, depending on the foul level. A job we just did of 100 fans, when completed, the refinery is able to shut down the rear fans on the banks and use just the front fans. And when you consider that it costs about $6,000 to run a typical motor annually, that was a savings to the plant of $600,000. Another advantage of the foam is it's customizable. We can custom design a specific solution for your needs. Since there's no one size fits all solution, and we see in refineries and chemical plants, foulants can vary from unit to unit. So if you can provide a sample, we can have it analyzed and then determine what product would work best for you. And then after the analysis, we will gladly come to your facility and demonstrate the cleaning process just so you see it works. We want to be certain we can do what we tell you we can do. We don't guess. Guessing will just lead to more problems and delays. Again, just some basics on the foam. Again, low pressure. It's compatible with all materials. It will not damage the fins or the tubes. It's non-corrosive. It won't harm the skin. It's biodegradable. Solutions can fall directly to the surface below or disposed of in a typical sewer system. The only problem, like we mentioned, is on vertical tubes. It's not a good application because the gravity works against the foam process.
Excellent. Thank you, Ray. 600,000 is huge savings. It's good stuff. I want to chat a little bit here and introduce a case study where we did a dry ice cleaning on vertical tubes at a gas turbine, HRSG, in Texas. This plant, when you see the pictures in a slide or two, you'll notice why they needed to take an emergency outage, but they're noticing huge back pressure issues, cooling issues, heat exchange, etc. So they had no option but to take an emergency outage. And they were working against an obvious time crunch because they were only afforded so long of an outage to do this. So we had a 3-step plan in order to successfully, safely, and effectively complete this job for the customer. First off, we had crews working in the area, coming off some other outage work. So we're able to mobilize a crew or multiple crews very quickly. So there wasn't much downtime to get started. The second part of the plan was to complete this work turnkey. We completed our own scaffolding, which eliminated the need for the plant to hire another contractor, wait for the lead time for them to get the product, etc. Well, we were able to handle this seamlessly for them. And finally, since they were under such a time crunch before this emergency outage, we employed a day-night shift in order to get the same amount of shifts in half the amount of days. So since there was no space restrictions, this is a standard vertical HRSG boiler tube application. We employed dry ice, the preferred choice. We completed the work with minimized mob time. We did it turnkey and day-night, which allowed the plant not just to meet the outage, but to get back up and running. So you can see here the before and after. If you only look at the left and you don't know what a dirty boiler tube looks like, you definitely don't need to be a rocket scientist to figure that one out, right? So the after, they look good as new. Our crew did a great job on this one. The results are fantastic. We went from 29 to 20 inches, 31% improvement, and the plant got back up and running and coming along. So some bottom line info on the dry ice technology. First off, it's great at moving major volumes of debris. What we're looking at here is the back end of an ACC, and just the nature of dry ice. you're creating zero waste byproduct in employing this technology. Dry ice is very flexible in different applications. You can use it on many different substrates, profiles, orientations, etc. As I mentioned, there's no environmental impact except when you need containment. So the dry ice, after it sublimes, you don't have to worry about. But all that liberated dirt or material, you will. So if you need to contain that, we can certainly do that for you. Finally, it's very important to hire the experts. Dry ice is not a job for rookies. I'm going to pass it to Ray to discuss a project where we completed a foam project. Right?
Thanks, Steve. Yeah, this is a refinery that had a heater with an SCR system. And due to the SCR constraint, they were not converting their NOx efficiently at the higher temperatures, limiting their production. We investigated a number of different factors: pressure drop across their system, their ammonia usage, ammonia slip, and their stack temperatures. And we found the problem was poor heat transfer on the tubes. What we did when we came to the refinery, we applied our foam solution through the top axis of the heater. We did the application and rinse a total of 3 times to achieve the customer's desired level of cleanliness. And during the cleaning, we were able to remove some ammonia salts, rust, and other debris fouling the tubes. And you can see here the before and after, which came out really well. The customer was very happy with the after. You can obviously see that. And I'll give you some information on the results that we came up with. These numbers come directly from the process engineer that we work for. After the cleaning, we were able to reduce the stack temperature 100 degrees, which is awesome, back to the original design temperature. And this resulted in an increased production revenue of $14,600,000 annually, and a fuel savings of $100,000. And after this, we calculated the net income for this company, and this resulted in net income of $860,000. And again, that's bottom line. That's what we're trying to help you with. So if you tell your management team that you added $860,000 to their bottom line, you're a hero. Sit back and wait for your bonus check. You have the data, the before and after data, so it's easily decalculated. And this is just one heater. I mean, in some of the facilities, how many heaters, boilers do you have? 2, 3, and others 20, 30, 50. You know, we'd love to help. If you're having any issues, please let us know. I just want to say thanks for your time today. And I look forward to speaking to you, and I'll send it back to Steve.
Thanks, Ray. I don't know if my boss is on this webinar or not, but if I saved him $860,000, I think he'd be happy. So thank you very much. As a great win. So we've discussed, you know, at high level and in detail, a lot of different factors here. I want to make sure that before we get into the Q&A section, we recap and make sure we cover and highlight some of the most important points. First off, do you even need a cleaning? And what are the signs that you might need a cleaning? First off, are you running hot? Second, are you noticing increased back pressure? Third, are there lower production numbers that you can't figure out where they're coming from? Your tubes might be something to look at. And finally, if you're afforded the opportunity to, you know, peek into your unit, either offline or online, is there obvious accumulation on the fins? That's a dead giveaway. Then, let's say you do need a cleaning. You've decided that's the case. What cleaning makes the most sense? There's 3 or 4 basic factors here. The type of the foulant on the tubes. We can inspect or take samples if it's a complete mystery. And there's custom foam formulas that can be developed for those problem child issues. The orientation of the tubes is paramount. Gravity is foam's best friend. So we want to look at this for a horizontal or diagonal tube orientation, or fin fan for that fact. Third, work with the pros. There's two tiers of completing these jobs properly. Understanding the foam and dry ice technologies is crucial, but so is knowing the plant equipment. You can't know just one or the other and plan on your contractor doing a thorough job. Finally, the right solution plus a trained crew will not just get your project completed efficiently and effectively, but most importantly, safely. That's it for our part. Let's see. I think I saw a few people raise their hands, and there is one question here. Ray, you've got a lot of experience in scheduling and zoning. How many fin fans can you clean in a shift?
That would depend on the situation. In a non-turnaround situation where the fans are operating, we would have to go to the control room, do the lockout tag out after each fan is cleaned. And when you're doing hot fans, they need time to cool down, so we would rinse them a little bit. You can't hit them with the solution right away, or the solution will just evaporate. So typically in a non-turnaround situation, we can usually do one fin fan bank per hour, so 12 in a typical shift. But in a turnaround shift situation where the fans are cool and already locked out, tagged out, you can usually do about 20 in a 12-hour shift.
Yeah, we know that, and that's a good question. I think it's a little bit of a loaded question too, because it always comes down to timing in any job at any kind of plant, especially with the cooling equipment. You don't have your cooling equipment up and running, period, or efficiently, the rest of your plant suffers. So that's why this foam technology is, a big winner many times on the side of the plant, because we can employ it quickly, and we can meet some budgetary. I got another question on our chat board. Have you cleaned heat exchanger valve tubes internally or externally by this technology? It can be due to cooling, water fouling, or other process chemicals.
Yeah, in that situation, Steve, as long as we have an inlet or an outlet on the exchanger on the shell side, we can definitely do that. Yeah, we do have products specifically for wastewater, so that's not a problem as well.
Excellent. I see a few folks raising their hands. If you have a question, please feel free to type it in the either chat or the Q&A, and we can address it. Or if you wanted to have a one-on-one conversation with Ray or myself, you can see our emails up there. Or please feel free to visit our website. There's a lot of information on our other services as well. So I think that's what it might look like. There are a lot of raised hands, but we're not seeing typed questions. So we're going to wrap this month's webinar up, and please stay tuned this time next month for our next webinar presentation. We're going to be talking on Catalyst and Catalyst services. And again, please feel free to reach out to Ray or myself via email, and we appreciate everyone's time. Have a great day.